If everybody will turn off their microphones, that would be good. So let me just go ahead and get started. I'm Leslie Martinich, a longtime member of IEEE and past chair of the Central Texas section. As Sir Reddy just told us, I have a long history in the tech industry as a software engineer, writing compilers, operating systems, and communication software. And I designed and architected remote procedure call technology, and I've led product teams at both startups and larger technology companies such as IBM and HP. If we had the chance to have this meeting in person, I would greet each of you at the door, and I would offer to do one of my tricks. I would offer to write your name upside down and backward on the whiteboard, and I would do that to get to know each of you and show you that each person's brain works slightly differently. Mine is especially wired for spatial skills, so I can write upside down and backwards. But mine is very badly wired for facial recognition. I'm very bad at that. I'm very good at spatial recognition. So one more thing, I'm not going to use PowerPoint for the most part. I just have a little section that I'll use in PowerPoint, and I'm going to show you a different way of communicating, actually a very old way, by talking. So today we're going to talk about critical thinking and how people solve problems, and also how you can improve your critical thinking skills. So let's get started. How do children learn things? How do students learn things in school? I'm going to name a few ways, but if you have your own thoughts, feel free to add this in the chat box. Let me see if I see the chat box. Let me see if I can. Nope. Yes, I see the chat box. So if you think of other ways, be sure to add things in the chat box. We have a very big group, and so the chat box can be very useful to us. So one way we learn as children is babies observe their parents, and babies observe their siblings. Let's see if I can mute you. Anyway, babies observe things. So that's one way to learn. Then when we go to school, we are taught to memorize things. We memorize the alphabet. We memorize the fact that the area of a circle is pi r squared. We memorize principles and rules for operating within the world. And later we do something else. We consult sources for information. We check a dictionary or an atlas or a cookbook to get information. Or the most common way we learn things as adults is we go to Google and search for the information that we want. And we learn things that we haven't already figured out how to do, or we haven't memorized. And all that is very good. But people like to learn in different ways. Some people like to learn by trying things out. And some people like to learn by reading about things. And some people like to learn by going to lectures. So I'm going to ask you to tell me how you typically learn. you can answer these questions. Can you see the poll that I've put up? Is that visible to you?
Yes, yes, sir.
We can see it.
Visible, madam.
Okay,
It's
so
visible.
I'm just curious how you think you best learn. Can you read the whole poll, or is it small?
It's readable.
Okay, good. Thank you so much. So do you learn by trying things out? Do you learn by reading and thinking about things? Do you learn by attending lectures? Or if you have a different way, post your way of learning in the chat box. So I see most people learn so far by, let's see. So most people so far learn by trying things out. Interesting. And some people learn by reading and thinking about things. Okay, well, I'm going to close that poll, but that's just interesting data to think about different ways that people learn about things. I actually like to learn about things by attending lectures. So there's different ways of learning. People have different ways to do that. So we're going to wait a few seconds, and then we'll be done with that. Okay, so I don't see that anybody has added anything in the chat box yet to talk about how they learn if it's not covered by the choices I gave. Okay, so if we're good at all those ways of learning, we can graduate from college and we can get a job. And it seems like that should be good enough. But it's really not adequate for solving problems. And I'm going to talk to you about an event that happened to my family. It was a big problem, and it was something that required some critical thinking skills. And so I'm going to talk to you about an event that happened quite a while ago. We lived in a two-story house on a creek. And one very rainy night, after I had put the children to bed upstairs, my husband came to me and said, "The water is rising and I think it might come into the house." We began moving some things from the downstairs to the upstairs, but water had never come up into our yard. Certainly it hadn't come up into our house before, and we'd lived there for a number of years. Soon the water began seeping in under the doors, and it got to be about a foot deep. My husband and I went upstairs, and suddenly the water crashed into the house through the front doors. It knocked the front doors off of their hinges, and all of our furniture began swirling, and some went swirling out the front door. And I'm going to show you what it looked like. So let me get that. Well, let me get the website up. All right, so So this is a restaurant, but it's very much like what our house looked like at the time. And you can't, let's see if I get this started. Water comes rushing in. Furniture is just flooding around, moving, swirling through the house and out the front door and falling off. And that's what the downstairs of my house looked like, except that I didn't have chairs on tables. I just had normal furniture. It was very, very, very scary. And let's see if I can stop sharing. Stop sharing. Okay. So that is what it looked like. Very frightening. So I was upstairs trying to sort the things I had moved from downstairs. And as I passed the staircase, I could see that one stair was being swallowed up every 10 minutes. And so I knew, and the water was already halfway up the stairs. And so I knew that we only had maybe a half an hour or 40 minutes and the water would be on the second floor of our house. And I realized that we would be underwater soon. And we had let's see, we had 3 small children. Our baby was 6 months old. We had a 3-year-old and a 5-year-old. And suddenly I panicked. My mouth was dry, teeth were chattering. I thought we were all going to die. And just then, my husband said, let's make plans to go into the attic. And that just took away the panic. And I said, oh, we have 8 more feet before we're overtaken. And he asked if I knew where the axe was. I said it was in the garage. It was already covered in 3 feet of water. Some scissors, not much, but I moved sheets and diapers and blankets and food and water to the attic. And once I had a plan, I was able to execute that plan. We were preparing to move the children to the attic. And then just as suddenly as it started, the water began to recede and carry all of our furniture and cans out the front door onto the street. So we were spared. And that was a terrible experience, but I want you to note 3 things. One, I encountered a problem that I could not Google to find out what to do. And you in your life will encounter many problems that you cannot just Google to find out what to do or how to solve that problem. Another thing I want you to notice, number 2, is that my husband and I have very different problem-solving approaches. He's more creative. He's more imaginative. But I am better at executing. Once I have a plan, I can just figure out how to make it happen. Boom, 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 and I execute. And a third thing to notice is that when you have a problem to solve, it's good to have people with different problem-solving approaches, because then when one gets stuck, the other one can probably nudge things into, they can nudge the problem loose. So at some point in our lives, we are at a place where we have to figure things out. Experience in search and memorizing data is not enough to help us figure some things out. I want to ask each of you, if you're not speaking, if you could mute yourselves. Thank you. Anyway, search using Google is not enough. Memorizing data is not enough. There's no data that I could have memorized that would have told me what to do in that situation. And fortunately, my husband had the good critical thinking skills and the good problem solving approaches to figure out what we needed to do was to move into the attic. So it's important to develop the critical thinking skills because search and memorizing is not enough. It's useful also to have a team. When you're working in a team, it's useful to have a team with multiple different problem solving approaches. So that's why it's important to have critical thinking skills. And now I'm going to talk to you about being open to some new ideas. Sometimes it's easy to have your own idea and you think, this is the solution, I've got it, I'm going to do this, and we're all good. But being open to critical thinking skills is really critical for you to, being open to different ideas is really important for you to be able to succeed. For many years, I worked with a man named Chip. We worked together at one company early in our careers and later at another company. We had offices adjacent to one another. We had a good deal of respect for one another. And we were both writing software. But Chip's code was very different from mine. I could barely read his code, and we were working on similar projects, or even sometimes the same product at one company or another. And we had offices adjacent to each other, and we had a good deal of respect for each other. So Chip liked to use recursive solutions, and I preferred a little bit more linear approach. He probably thought mine was boring. I thought his was strange, but that's okay. We had different approaches. But during our lunch break, Chip would often come over to my office and we would read a logic puzzle book from a logician named Raymond Smullyan. It's an old book. The title of the book is, "What is the name of this book?" So right there it tells you that it's about logic puzzles. So we'd read a puzzle and then we'd go back to our own desks to work out the puzzle. And I'd usually come up with a solution and then I'd get back to my job. Chip would go home and he would work on the puzzle. And then the next day we'd get back together and I'd have one solution. But Chip would come back with often 3 different solutions and a proof. I was happy to come up with one solution. That was good enough for me. But our approaches were so different. And that can often be very helpful at solving problems at work. So the lesson here is to be open to new ideas. Are there any questions so far? If there are, please raise your hand, turn on your microphone and your camera, and I'm happy to answer any questions if you have them. All right, I'm going to take that as no questions, but also be sure that that you put any questions that you would like into the chat box. So we've talked about why it's important to have critical thinking skills, because you will encounter problems in your career and in your life that you can't just Google or you haven't memorized a solution to. And we've talked about being open to new ideas. Now I'm going to talk about applying principles. And actually, I do have some slides for this section. So I'm going to bring up PowerPoint in a few minutes. We learn principles for our disciplines. I believe everybody here is an engineer. My discipline is software engineering. And among the principles of software engineers are never corrupt data, never fail to release memory, otherwise your system performance will degrade until it stops. And 3, understand your trade-offs. Perhaps you want to optimize performance. Perhaps you want to provide additional functionality. Perhaps you want your system to run in multiple environments. Perhaps you want to optimize security. There's lots of different trade-offs that you will encounter. So when you encounter a problem or a question in your work, you have to apply the principles of your discipline and apply them to the information and the problem at hand. So for this part, I'm going to actually bring up an example from the field of ethics. It's about applying principles to an ethical dilemma. And now IEEE has a code of ethics, but I'm going to use a more ancient code of ethics, those that have been developed by philosophers over the millennia. So let me bring up this PowerPoint and start to share that. PowerPoint and share some content. So PowerPoint. All right, so first, before I move further, can you tell me if you can see my screen? Yes? Okay, great. So I'll put it in slideshow mode. When we have an ethical dilemma, we take the principles from the field and we apply them to the information at hand. And an important part is to practice. And this is something that I use extensively in an in-person workshop, at work. It is practice. Practice in different scenarios over and over and over. And that will lead you to that center part, the critical thinking skills. So we're going to try it out, and I'm going to give you some principles first, and then I'm going to give you some information, and then we're going to discuss that. So Aristotle, a Greek philosopher, he was focused on living a virtuous life. And I've tried to make this simple by coming up with a question that you can ask to reflect the principle there. And the question for Aristotle that I ask is, can you sleep at night? And another philosopher, 17th, 18th, 17th century, Immanuel Kant from Germany, he had something called the categorical imperative. Categorical means all different categories. Imperative means you must do this. So for Kant, the ethical principle is, what if everybody did this? So we can often ask that question when we see an ethical violation. What if everybody did this? Later, we had a couple British philosophers, Jeremy Bentham and John Stuart Mill, and they came up with some principles that are known as utilitarianism. And for them, the question that I would ask is, what is the greatest good for the greatest number? So we're developing a number of different principles. And Mahatma Gandhi, who lived about 100 years ago, up to 50, 60 years ago, said to be the change you wish to see in the world, and suggested firmness in truth and welfare of all. I could have done pronunciation, but I didn't on those words. So the question I would ask for him is, am I acting with integrity? So here's a summary: living a virtuous life. What would your parents think? Can you sleep at night? The categorical imperative from Kant. What if everybody did this? Utilitarianism, what is the greatest good for the greatest number? And then Gandhi, firmness and truth, welfare for all. Am I acting with integrity? So those are some ethical principles. So now I want to describe a problem, and this is going to be an ethical dilemma. So if you are a teacher, if you are a professor, you may have already encountered this problem. And if you are a student, you may have encountered a similar problem, but in any case, this is a not uncommon thing. So the class is given a problem, a project, and it's worth 25% of their grade. So it's really a significant part worth grade. And for that project, all team members will receive the same grade. And each team solution should show mastery of the subject. By the way, the team size is 4 people. The team is free to cite sources outside of class. They can certainly Google something and then refer to that. But if the report includes plagiarism or stealing ideas without citing them, the report will be given a mark of 0. So it's a really harsh penalty for plagiarism. You get no points. You're done. Oops, that's my cuckoo clock. So one team turns in a report with 20% of their work plagiarized. And you know which person plagiarized the work. That's a bad situation. So what are you going to do? And I want to tell you, I encountered this situation myself many years ago, and I had to consider, what was I going to do for this team? Was I going to give every person a 0? Or was I going to let them try again? Or what was I going to do? So here's the principles that you can apply. These are very simply put principles. Can you sleep at night? If you gave everybody a 0, for example, could you sleep at night? What if everyone did this? What if everyone just skipped over problems of cheating? What's the greatest good for the greatest number? And are you acting with integrity? All those things are questions for you, for what you are going to do. What are you going to do in this case? So I'm applying these principles to the information at hand. So there's the principles that I just mentioned, and there's the information. The group project is worth 24% of the grade. All the team members receive the same grade. Team solution should show broad mastery of the subject. They can cite sources, but they can't just use sources without referring to them or citing them. So what are you going to do? So let's, I'm going to get out from that and stop sharing. Let's see. Stop sharing. And now I'm going to ask you what principles you think would be important to you in this decision that you're going to. This is your decision about how to deal with this. Here we are. Return to meeting. Can you see me and hear me?
Yes, we can see you and hear you, but I think you haven't stopped sharing. Yeah, right away.
Thank you. That was my problem. I thought I had stopped sharing. So I'm going to bring in some other questions now with a new poll, and this one, in this poll, the question we're facing is which ethical principles do you think you would deploy to help you figure out what to do in this particular case? So we have the principles as answers for each of for answers for these questions, and I see we're getting some responses. Thank you. But think about what you would do. And I want to mention something. I may have mentioned it. I actually did encounter this problem in my teaching. And I'll tell you what I did after we have after you answer the poll. But keep in mind, there are no right or wrong answers. This is just your way of thinking about how you would consider this ethical problem. And see, some people say they are going to add their own principles to the chat, and I'm looking forward to seeing that. We'll close this poll in about 30 seconds. And it looks like a large number of you would use the principles of utilitarianism. What if everyone did this? What if everyone just did whatever you decide you're going to do? You might decide you're going to give everyone a 0. You might decide you're going to let them do this over. You might decide you're going to give the one person a 0, etc. So and many others are considering, are you acting with integrity? Are you doing the right thing? I'm sorry, I misspoke a minute ago. I said it was the utilitarian choice. What if everyone did this? That's actually Kant's categorical imperative. That's the Kantian approach. Okay, so I'm going to close that poll. We have a lot of thoughts here. Let's see how I can close the poll. I don't see how I can close the poll, but in any case, now I'd like to ask you your thoughts. What are your thoughts? And please feel free to speak up or to post something in the chat box so that I can see your thoughts. Tharun, did you want to post? Did you want to say something? Your speaker came on. All right, we have a very quiet group here today, and I don't know if that's because of the technology or something else, but let's see. So I'm going to tell you about how I handled this. I thought about the principles of, am I acting with integrity? Can I sleep at night? What if everyone did this? I probably didn't think about the greatest good for the greatest number. I think that one didn't apply to me, for me, but it can certainly apply for you in this case. And I decided to fail the one person who was doing the plagiarizing because it was so blatant and so massive on his part. And I gave the 3 other members of the team the opportunity to rework their report and resubmit it for a new grade. So I didn't fail them all, which is what the rules said I should have done. I didn't just skip over the obvious plagiarism. It was very, very obvious. And I just considered what I thought was the best solution to that problem. And then I could sleep at night, and the guy that was plagiarizing was very unhappy with me. He didn't like it. He called me and complained a lot, but it was obvious. So I said, no, I'm going to have to fail you for this class. All right, so that is one way that we can use our critical thinking skills, applying principles to the information that we have at hand. And so Dr. Bindu says, penalize only the one who is guilty. And thank you. That is exactly what I decided to do. Because I could easily tell who was the one who was guilty, it was easy for me to do that. And I think that's a reasonable approach. So that's an example of an ethical problem and applying ethical principles. Now, you may be working on a big power engineering project, and you may come across a desire for taking some shortcuts. And you have to consider, are you going to take those shortcuts? Is it going to save the company money to take those shortcuts? And if so, is it going to create a problem? Has anyone encountered this kind of situation, taking shortcuts in an engineering project? Maybe you don't want to speak up if you have, because that's a very, very difficult and painful one. But I think the ethical principles apply to that, but also the principles of your discipline, whether it's electrical engineering or some other kind of engineering, whatever the principles for your discipline are, those can be of guidance to you when you are faced with a problem and critical thinking. Perhaps we have some folks who'd like to chime in. All right, so the next part of my talk is about some techniques you can use for critical thinking. And you can use these in many different ways. And I'm going to talk about analysis and synthesis. So analytic solutions and synthetic solutions. So the first one I'm going to talk about is analytic solutions. Now, what do I mean by that? I mean, that is a top-down way of approaching a problem. You have a project you have to do, and you got to figure out, how am I going to do this? And what you do is you break it into its parts, you analyze it, and then you iteratively solve the problem. You analyze it into its parts, You solve one part, you solve another part, you solve another part, you solve another part. If you're working with a big team, you break it into its parts, and then different team members take on different parts of the problem. So very often in industry, we have a project or a problem that's just too big to figure out all at once. And so you have to break it down. And I'm going to talk to you about a situation in which our team, a team I was working with, or a team I was leading, was designing and implementing a remote procedure called technology, RPC. We had a team of about 7 software engineers, plus we had testers and we had documentation writers, project coordinator, customer support engineers. We had a lot of different people, but keep in mind that we had about 7 software engineers. So once we knew we were going to start this project, I gathered the team into a conference room where we were going to figure out how to tackle it. So the project had not been done before, so it wasn't something we could look up or reference or research to figure out how others have done it. We certainly could use research to look at the research from the universities, which we did. We sat down, I gathered the team together to tackle this problem. And we sat down in a conference room and we discussed what we would need for the project. We would need an engine to run the whole thing. We would need a way to pass requests and parameters from one computer to another. We would have to have a small user interface. We would have to have APIs. We'd have to have lots of different technology parts. And once we had a starting place, we broke each piece of work down until it was something that could be done in 3 to 5 days. And then I asked who would like to do each part and what were the dependencies and constraints for each part going to be. For example, the user interface or the APIs needed the initial design to be done first so that, let's see, first we had to do the initial design and then later we could do the APIs because you couldn't really do them until you knew how many parameters there were going to be and how you were going to pass them and how you were going to get results back. So we had to look at the constraints. We had to look at what parts could overlap in time chronologically, what parts had something to be done completely before the next thing was started. I'm sure that you guys have all encountered project planning where you have to figure out those sorts of things. So I asked each person what they would like to do, and I made sure that each person had parts of the project that they really wanted to work on, that they were passionate about. I love working on this part. I really want to work on that part. And so I gave parts to them, and we sort of tracked how much work each person had to do. And then we divided up those that nobody really cared about. So some things nobody really wanted to do, but at the end, we just divided those up. So in order to schedule the work, and this is something that I don't often see, but I think it's a very good management approach. In order to schedule the work, I asked each person for an estimate of the time they would need to complete a given chunk of it. So how much time do you need to complete this send API? Maybe the person would say, I think I can do that in 2 days. So I took that time and I doubled it. So if the engineer said, I think I can do that in 2 days, I would say, well, what if I allocate 4 days? Do you think that would be adequate? So I doubled the time. Now, the reason I did that was that I knew that each person had other things to do. They had to answer email, they had to attend meetings, they had other things they had to do. They weren't going to be able to focus 100% of their time on completing that task. So I doubled it, and then each person felt that they had an adequate amount and they've got work they were interested in doing. They had a reasonable schedule for doing it. And they felt like they owned that schedule. They had made it up. They had broken it down. They had committed to the time that was allocated on the schedule. And the people on that team were very committed to that project. The product was completed on schedule and very cleanly. Our test department could find very few problems. And the reviewers of the ultimate product referred to it as our company's hidden jewel. Hidden because it's really under the covers. It's, it's the background of a software product. But the message of this story that I'm telling you is, first you break down a problem into its component parts, and then you allocate the resources that in a way that allows each person to take ownership of the part that he or she is working on. So that is what I would call a top-down or analytic problem-solving approach, and it's most commonly used. It's the most commonly used approach in problem solving, and that is break it down. Now I'm going to talk to you about another way to approach problem solving, the complement of the analytic approach. So the analytic approach is to start at the top. You've got your big problem, you break it into parts, then you break those parts into further parts, and you've got a tree structure, and you figure out how you're going to attack it. Now, the other interesting problem-solving approach is synthetic approach. So you have analysis is one way, that's the top-down way. The bottom-up way is a synthesis. So you synthesize or combine ideas to create a new solution to a problem. And I don't think people often think about using both, but really it's a great thing to do. So instead of breaking something down, we are building up a solution bottom up. So I want you to consider a technology that you're familiar with, and now consider a problem that needs to be solved. How can you utilize the skills in your domain to solve this problem out here? Well, maybe you can use the skills in your domain and add them to another domain to come up with a solution. So this is the fun part. This is the creative part. This is where you take two things that haven't been used together before to solve a vexing problem. So I'm going to give you some examples. Many years ago, maybe 10 years ago, a friend of ours, Dr. John Tisdale, told us that he was working on a cure for sickle cell disease. He's a doctor who works at the National Institute for Health. He does research and understands the genetic contribution to diseases. Well, that was a long time ago. He has been working with his understanding of the genetic component of diseases. And in recent years, a new technology became available to him, and that is the CRISPR-Cas9 gene splicing technique, for which the creators won the Nobel Prize this year. So Dr. Tisdale is trying to change a person's genetic code and cure their very painful ailment. He took one thing he knew, genetic diseases, and applied a new technology to that, to the problem to come up with a completely new solution. That's a synthetic approach. So, and you know, I'm going to take a little diversion here. I think there's a lot of interesting synthetic approaches now in pharmacology. So I think there's some very interesting work being done in that area. So let's consider some other synthetic solutions to existing problems. And I'm going to name some, but I want you to think of others that you can come up with yourself, because remember I told you earlier, I'm not the creative one in the family. I'm the one who executes and gets stuff done. My husband's the creative one. So just keep that in mind. I need you to be the creative ones because I'm the executor. So right now we have technology for electric vehicles, and we have the technology for solar power generation. Why not join those two technologies together to invent a solar powered car? Now, I know that's already being done, but you might be able to take your knowledge of solar power generation and your knowledge and somebody else's knowledge of electric vehicles, depending on your domain and other people's domains, and think about ways you can join those together to form a synthetic solution. Remember, I told you, this is the really fun, creative part. A problem facing, second problem for many communities in the world is the lack of clean drinking water. Also, note that many communities are near the coast. So what about joining the technology for desalination along with the technology for harnessing wave power to generate clean drinking water? That seems like two completely different technologies that can be joined together to solve a problem in the world. This is the kind of creative critical thinking that I want to encourage those of you who are students as well as faculty members to really think about, because that's how you can really advance your career. Third, think about applying the CRISPR technology to another genetic disease to come up with a creative solution to another ailment. There are plenty of genetic ailments out there, genetic problems, and people can maybe solve some of those. In a completely different area, consider using GPS technology along with clever routing algorithms. And so this is really three things: GPS technology, routing algorithms, and a dispatch service to create a smart router which will calculate the shortest distance for service repair technicians to handle calls. Now, you are familiar with routing yourself from one place to another, but what if you were a big service technician company and you had repair people going to various parts of the community? So you have, say, 50 repair requests in a day and 20 repair technicians, and there's variables like what's the location, how long is it going to take, etc., etc. But you don't really need to know how long it's going to take if you can have an on-the-fly system so that you dispatch the service repair technician to the first spot for the day. When that service repair technician is done, then you've got a list of, say, 30 more service requests, and you can dispatch them to the next one that optimizes their distance. And it can also optimize other things. It can optimize their language skills. What language do they need to speak for that site? That can optimize their technical skills. What is the technical problem, and do they have the skills to handle it? There's a lot of variables, and it makes for a really interesting algorithm. So that's one that takes multiple inputs from different domains, GPS and routing and dispatch, to create the smart router. Now, I think there are already those things in existence, but it's just an example of synthesizing a couple different technologies. So those are all examples of synthetic solutions to a problem, and creating the synthesis of two different technologies to come up with an entirely new solution. So now I'm going to post a poll to ask you which one you would like to be involved with. So I'm going to open the poll. Which of these projects would you like to be involved with? Would you like to combine two technologies to, it's really hard for me to see this. Would you like to combine two technologies, say wave power and desalination, to create a source of clean water? Would you like to combine technologies for solar power and electric vehicles to create a solar car? Would you like to use CRISPR-Cas9 and the knowledge of genetic diseases to create a cure for a genetic disease? Or would you like to combine GPS technology with routing algorithms and a dispatcher to create a smart router? So I'm going to leave this poll open for a few minutes and see what you think about this. And I really would, the other choice, E, I'll enter my own idea in the chat box. So those are certainly, I don't want to limit you to the first four ideas that I mentioned. This is for you to be really creative, and I want you to think of how you would do this. What would you do? What do you have special domain expertise in? Where's there a problem? And what other domain can you combine with? So I see we have a lot of people who would like to do wave power and desalination, and I think that's excellent. We're going to have such a huge, huge problem of clean water availability in the world in the next 20 years. That's a huge problem. And lots of people want to build a solar car. And 3 people say they're going to post their own ideas in the chat box. So I'm looking forward to that. So we have about 30 seconds left. So Mrinali says, making educational resources available for poor children with technology ubiquitously. What a wonderful solution. Okay, our poll is closing, and so we have a lot of good ideas. Rakshith says, try and use turbines used in making hydraulic energy to also use it with tides, since tides create huge forces and would be a way to create energy throughout the years, because with rivers, it's only possible if it's a perennial one. Otherwise, we face shortages in summer. Yes, I think using the tides, and India, for example, has a huge coastal area. The tides are there, they're available, and making hydraulic energy with that is a great idea. Thank you. I love these ideas. Use technology to avoid, I think, crop loss due to pests. That's a great idea. Yep, I got the crop part right. That was my guess. I was using my critical thinking skills to figure out that cross meant crop. Thank you. How about some other ideas? People can think of good ideas, and this is really your chance to be able to use the thoughts from this workshop to maybe create an idea that will change the rest of your career. Maybe it'll change the world. Use technology to reduce the sound created by ceiling fans for sound sleep. Great idea. Yeah. So I think you've got the person who's listed as HVK. You're coming up with creative, doable ideas. There's technology for parts of those things. You can combine it with technology for other parts, and then you have a new solution to an existing problem. Wonderful plan. So now that you're thinking, I encourage you to continue posting things in the chat so that everyone can see the ideas and you can talk to each other about what ideas you would like to follow up with. All right, so now I'm going to go back to the PowerPoint and see if I can share that. All right, so let's see, slideshow, play from current. Okay, so one of the takeaways from this workshop is that having diverse teams yields better solutions. And I have many examples of that from my career where I had one person who was very meticulous, very thoughtful, very studious, and worked in a particular way, and another person on the same team who would just jump in and start doing things and trying things out without really studying the problem first, but eventually the two of them solved problems wonderfully. And it was because when one person got stuck, the other person could break them loose. When the woman who was very meticulous would encounter a problem she didn't know how to fix, the man who was just jump in and try it out, would jump in and try some things out and maybe break loose the problem. And when he had tried everything and couldn't figure it out, he would ask her, and she understood the technology very well, and she would be able to provide a solution for him. It was a really good example for me as a young manager to see that we really got better solutions if people had different approaches. And how do we get people with different approaches? Well, we hired people with different backgrounds or different challenges that they faced. And so my husband was making a joke with me, said, does it make sense for diversity to consider height, short people and tall people? And I laughed and said no, but then I realized, it does make a difference. I am a very short person. I used to be 5 feet tall. I've shrunk a little bit. I'm 4'11" and a half, and I treasure that half. But I realized that because I'm so short, I have figured out ways of solving problems that other people don't face. For example, if I need to look on the top shelf in a hotel room to see if I left anything in the hotel room, I can't jump up and see it. I'm just not tall enough. But I know that I can take a mirror and hold it up in the air and look behind myself and see what's on top of that top shelf. I have a different solution and a different approach. Tall people have completely different approaches than me. So even something as simple as height and diversity of height can mean different problem-solving approaches. And I say this sort of jokingly, but I do want to say that when you're working on a team, it's great to have people from different backgrounds. Another takeaway from today's workshop is be open to new ideas. So you might think you have the solution. I always did when I was young. I always thought I had the right solution. And just like when I worked on the logic puzzles with Chip, I just would come up with the first solution that I could see, but he would come up with 3 different solutions and a proof, and he would have a different approach to a problem. And it made me realize that I have one way of solving problems. He has another way. We work really well together as a team because we can combine our approaches to solving problems. The third takeaway is to consider information, apply principles, and then practice with that. So I gave you the examples from ethics. We have principles of ethics. We had information. We had a particular problem. And then we practiced thinking about that problem. And we didn't, in a workshop in person, I would have you break into teams of 3 or 4 and work through problems like that. Problems not just from teaching and ethics, but problems from technology as well. And then the last 2 takeaways are to use analytic approaches, use a top-down approach for critical thinking and problem solving, and also use a synthetic approach, namely a bottom approach to problem solving. Those 5 takeaways can help you to have a better future in terms of not just knowing a lot of information that you've memorized, not just being the best searcher on Google that is on the planet, but figuring out how to do stuff that you have never encountered before. And I'm not at all discounting the value of memorization and search on Google. Those are hugely valuable. But on top of it, you also need this critical thinking skills. So let me see if I have another. Oh, yeah. So the takeaways, I just went through these takeaways. And now I want to ask you if you have any questions for me. And I've put my email, 3 different emails for myself. Pick your favorite. And you can contact me anytime, and I'm happy to work with you.
I have a question, Leslie.
Good.
We have an event place in common.
I'm sorry, I couldn't quite hear you.
Yes, are you able
You
to
wanna
hear
type
me,
it in the
madam?
chat?
Yeah.
I can hear you, but you were breaking up as you asked that.
We assess the students.
I don't know, but I have posed the sorts of questions, but based on the domain that I'm working with particular people. In their domain, I will pose questions that involve solving the problem in a way that they haven't figured it out before. I don't know, I don't have a resource for you on that. I'd be happy to work with you if you have a particular thing you would like to accomplish. I'd be happy to try to solve that for you.
Okay.
Or find
Okay.
a solution.
Okay. Thank you. Darwin Jose Raju sir, any questions?
The session is fine.
So a couple other comments in the chat. Kunal Buyan says we can reduce the power consumption in a combine harvester by using a mobile thresher. And that is completely out of my domain of knowledge, but I'm going to trust you on that, Kunal. I think that's a great idea. Rakshith says we've discussed about critical thinking abilities, i.e. the bigger problems which are given a particular time period to compete. Could you please also give tips on critical thinking in situations you have to react spontaneously, as in quick thinking? Yes. The example that I gave you where my husband thought of going into the attic, that was quick thinking. We were in a very chaotic situation. If you're doing a test or you're trying to solve a problem and you have to figure it out spontaneously or on the spot, the more practice you have with critical thinking skills, the more practice you have, the better you will be at it. So I encourage those of you who are professors to provide open-ended queries to your students, and ones that don't have a wrong or right answer, but ones that can allow them to explore how to solve the problem. You'll note that none of my polls had a wrong or right answer. They were to get you thinking, and they were to get you to practice thinking critically. So the way that I would answer your question, Rakshith, is to practice using your critical thinking abilities. Go ahead.
Professor Manuel Castro, any questions, Professor Manuel?
Oh, yes, I was following the comments. I believe this is a really thing that you may have in the mind to try to be, if you can have this kind of creative thinking actively or passively. Should be done, it should be feasible, these two different approaches. Try to allow the people that may have or invest some time on questions to do this, or how they will do it in a passive way when you are aware of these kind of things. What should be not better, but what should be different and should be feasible?
Okay. Okay. Yes.
Thank you, Manuel. That was a very good point. Active and passive ways of passively observing people making critical thinking decisions and actively participating in the critical thinking that someone needs to solve problems. And it's so fun if you're young and fairly new at it to watch really, really bright, intelligent people solving problems and observing how they do that. When I was an undergraduate at the University of California, San Diego, we had a little coffee shop or a restaurant that was outside, and people would sit around big tables, and the faculty members from physics and sciences and government and all sorts of departments would sit around and they'd talk, and the students could just sit with them and listen. And I was listening one day when two Nobel Prize winners were discussing something that had happened just that morning, and that was a Russian spaceship had crashed or something like this. It was a long time ago. And they sat there and they took the data that they had, the information they had, and they applied various principles to it, and they came up with hypotheses right there in front of me of how that happened. And I'll never forget that. Watching them was so good. And that is passive, to your point, Manuel, that is passively participating in critical thinking. So everyone should engage in that if they can.
Okay. Okay. I think Darwin Joseph. Darwin Joseph. Yeah. Can you give the concluding remarks and vote of thanks, sir, on behalf of IEEE Education Society Madras chapter?
Thank you very much.
Yes, sir.
Yeah, Manuel, sir. Yeah.
Thank you. I only like to say thanks again for the invitation worldwide to all the people that was connected today. It was really fun to see a lot of colleagues there in many areas of India, Asia, and of course, United States and Europe and so on. And thank you to be here. Leslie, it was a real pleasure to be you in connection. I'd like to say you hello from Edmundo Tobar, and he cannot go today, and is the current president of the IEEE Education Society.
Please give my regards to Edmundo.
Thank you, and I will do it. And I will bring you the words, and please you can close the session today. And I hope to have more new sessions in the close future.
Bharti, madam.
Thank you so much for inviting me today, and thank you for your very nice comments. Can the feedback link be shared, as I got disconnected for a few minutes? I'm not sure. That's just the chat.
Okay.
I think that's just the chat.
Just request Darwin Jose Raju sir to give the closing remarks and vote of thanks for today's program.
7 minutes.
Yeah.
Good evening to everyone. The today's session is very useful. So this session is useful for teachers as well as students for critical thinking. First of all, I would like to thank Madam Chief Guest Leslie Andrich. You are spending time for us. So on behalf of Education Society of Bangalore section and Madras section, thank you, Madam. Next, main organizer and have take most pain to organize this event. Dr. Shivareddy sir, they are taking most time and taking care everything. So thank you very much, sir. And actually, more than 300 participants registered, but only 80 plus
Yeah.
participants are attended. 89 participants are attended. Thank you, everyone. I hope that
Yeah.
this event will be very useful. Thank you.
Thank you, and I really appreciate your inviting me to present, and I look forward to future workshops. I'm happy to do them for you anytime, and I welcome your
Thank you, Leslie
suggestions.
Martinich.
Please feel free to contact me by email. lmartinich@ieee.org is a good way.
Thank you so much, man.
Yes,
Yeah,
thank you.
Thank you so much. Thank you. Yeah,
All right.
we'll. Yeah,
Okay.
yeah. I think we will close the session, and I would like to thank Manuel Castro sir for having come for this particular session. It is a pleasure to have you, sir.
Excellent.
everyone.
So thank you,
Bye.
and
Thank
I
you.
will sign off,
Thank you.
and good night.
Yeah,
And I hope you
good
have
night.
a wonderful evening. Bye-bye.
Zoom.
Thank you. Thank
Bye-bye.
you. Bye bye.